Hi, everyone. I'm Chris Grove, Director of Industrial Security for Indegy. And first, I want to thank Sid for the excellent framing of the conversation. And it's an honor to present with you, Sid. Thanks for all of your effort in this industry. So what I intend to do is show you our tool and how everything that Sid described actually relates into the field and what it looks like in practice. So first, I want to just briefly introduce Indegy. What we focus on is preventing operational disruptions caused by not just cyber threats, but also malicious insiders and human error. So we found that these tend to go hand in hand, and a lot of times the same set of tools is able to address those risks because they're very similar in a lot of ways. And if we look at what Sid was talking about, in particular the cybersecurity maturity model from the ARC, and relate that down into a process that we can work through to implement that, the first thing we need to know about the industrial environment, as Sid highlighted, is you need to know what's there. So asset inventory is a very important part of starting this entire process. Next, once you know it's there, you need to monitor who accesses that stuff and how these things change. Also, where are they coming from, and the sources of these accesses and communications. We need to understand where our risks are, as you can see here in the third part of our process. What kind of vulnerabilities do we have in our environment that could be taken advantage of on our industrial devices or on our network? Are we configured properly? Are we following process? There's a lot of different risks that could be addressed with a properly implemented asset inventory and anomaly breach detection tools. Finally, being able to enforce the policies that we have in the organization and getting alerts when things happen out of the ordinary. These are all important parts of being able to navigate the maturity model and having a good system in place to keep track of all of the stuff on the industrial side. So the way that we work, or the way our technology works to implement this is through two different pieces that we have. One of them is a passive technology. Essentially, we're monitoring the network. We're just listening to the transactions, and we're looking using deep packet inspection deep into the transactions, and we're able to look for anomalies, not just at the high-level network communications, but also anomalies within the behavior of the people that are operating the devices. For example, 30,000-foot view, it might be normal to see traffic between an HMI and a PLC. But if you get down to the 1-foot view using deep packet inspection, you may see that instead of using the usual commands, it's doing something like updating the firmware or some dangerous activity on that device. So you need to have multiple perspectives from high level into very detailed inspection of that traffic. The next piece that we use is an active component that is agentless. If you recall, Sid outlined two different models for being able to get more information. So our active component works with the passive component to give us a tremendous level of detail about the different devices that we're managing, as well as the state of the code that's on those devices. Because asset inventory goes beyond just managing hardware. A lot of times the value is in the software, the recipes that are inside of the devices. So we need to manage that as well. That's an important part of understanding and being able to mitigate risk in the operational environment. So what I'm going to show you today to kind of reinforce all of this and show you what this looks like in practice. First, we're going to pretend that this environment has been infected with malware, and we're going to look at what kind of behavior would we see by using a tool that gives us visibility into that network. Also, we're going to start out with an alert telling us that something new is on the network. And I think that one is pretty interesting because, you know, on the IT side, the tools that you would use for the IT side, they have a different set of challenges than you would have on the OT side. Their world is more about addressing cloud and bring your own device and a lot of comings and goings and things like that. On the OT side, we don't have that as much. The environment tends to be a little more static. We can get a baseline of what it looks like, and chances are we're not going to modify or we're not going to change the hardware out of an industrial turbine as often as we might see changes on an IT side. So once we understand the network, getting information about a new device connected is something that affects both asset inventory as well as be a potential breach on our network. So we'd want to know about that. So I'm going to show you what that looks like. And then also I'm going to show you when a hacker breaks into the network and they write malicious code to a PLC, how would we know that? What's it look like using an anomaly breach detection system? And then we're tying all this together. We're going to use a forensic analysis along the way to kind of answer all these questions. And that's what I'm going to show you in the GUI. As I switch to that, Dana's going to take over and...
Yeah, great, Chris. As you switch, I'm going to launch our second poll question. So you should see it in front of you right now. So the question is anomaly breach detection an area in your organization that is owned by IT, owned by OT, a shared responsibility, or undecided? Please submit your response. And again, we have almost 50% if you responded already. Very interesting. We'll give you a few more minutes. A few more seconds, I mean. Okay, if you still want to respond, the last 5 seconds before we close the poll. And I'm going to close the poll and share the results with you. So it looks that about 37% are owned by IT, another 34% is a shared responsibility, and in 26% of the organizations it's undecided. Very interesting. It doesn't look, or only 3% of the organizations, this is a responsibility of the OT organization. So thank you for submitting these votes. And with that, I'm going to make Chris the presenter. Chris, are you ready?
Ready.
Okay. Then the floor is yours.
Can you see my screen?
No. Did you share it?
You have to hide. It says you organizer must hide poll results to enable screen sharing.
Good point.
There we go. Okay, can you see me now?
Yes, we can.
Perfect. Thank you, Dana. Great. So back to the use cases that we were just discussing, which is potential malware attack on the network or hackers attacking stuff, etc. So let's say that we start our day, we come in and we have our first alert, and we're just going to start our investigative process with an alert that we received. It says that it's in my email, and it says that we have a new asset on the network, and I have a timestamp for when it was there. So first, is this an anomalous network event, or is this an anomaly in my asset inventory? I would say it's both. And one bad thing could lead to another. It could be that this guy got on the network first, and now he's going to go do bad stuff. Or it could be that he got on the network just to do the bad stuff. Either way, there should be two different places that I should have some red flags about this. One would be in my asset inventory system. One would be in my network anomaly breach detection system. However, I'm going to use the Indigi product to demonstrate how all this works, and this platform provides both. And it's very important that they are in the same product because they work together to give you a much greater level of understanding of what's going on and who's connected to what, who's talking to what they're doing, etc. So the first screen that we're looking at now is the, by the way, can you confirm you guys can see the GUI right now?
Yes, we can.
Just want to make sure that, oh, excellent, thank you. So The asset inventory screen that I'm going to show you in the beginning here is one of the few tools that we're going to use in our forensic investigation. So remember, we started our day with that alert. We know something new is on the network. So we come in and, you know, I can see at a high level what's going on in the inventory, and everything is automatically done with Indigi as far as populating this asset inventory with all the different makes and models of industrial controllers, my engineering workstations, my HMIs. As you can see, each chunk of the table here is a different category of stuff that I'm managing in my industrial environment. And having good understanding of what's running is not that hard when you have it all automated for you. It's all under the hood done. As something changes in the environment, we get updates about stuff and things are categorized appropriately. So this gives us a really easy way to understand what's in the environment. And this is the first step to, in my opinion, the most essential step into cybersecurity is understanding what's there first. And not even just from a hardware standpoint, how that stuff is configured for running. For example, I can see these devices and get some basic information about them, but I also want to know more details, like what firmware version is running on this particular industrial controller, and what's the serial number of a particular controller, or other deep level details that I might need for other types of use cases to solve. So an asset inventory product should do a lot of different things for you, including having multiple lenses from which to be able to see the inventory. So for example, if I just want to manage a particular plant, I can view my asset inventory at a plant level and see what's there. If I just want to manage a particular section of my plant, I can instantly see all of the controllers, the HMIs, the servers, etc., that are in section 1 of my plant. Here's section 2 of my plant. So being able to manage this stuff and see it from different perspectives from an organizational standpoint is a great way to understand what's in the environment first. And like I mentioned, you want to be able to also see the code that runs on these devices, which I will show you towards the end of my demo. So because we're chasing an unknown machine on our network, something new that just appeared, the first place that I might see an anomaly is in my asset inventory. So for that, I'm going to just look at machines that are unnamed. And that means that I'm not currently managing this. So first off, I can see that I have 2 that I need to take a look at. I actually got more than one alert. I just showed you one alert. So the first thing is, let me look at this guy, unnamed 96, and I can see the first time and the last time that he was on the network. He was only there for 1 second. So I find that pretty suspicious, because even engineers that come and go from my plant plug in longer than 1 second. So I definitely want to raise a red flag around this and go do a little bit more forensics investigation around this particular device. And moving on, oh, by the way, the IP address is also something that would raise a red flag. I'd probably want to take a look at that as well. Next, I could see my second unnamed device that I don't understand much about because he's not in my inventory, but I know that he exists. And you can see that he was on the network a little bit longer. In fact, as of this morning, he was still on the network. So I first saw him shortly around the same time that I saw this other guy. So that's 2 machines now that are in my network that I don't know much about. That would be my first set of alerts to raise an anomaly from an inventory standpoint. Second, I would raise another red flag about the category that these guys were in. The fact that Indigi picked them up as engineering workstations is suspicious, because if it's just somebody connecting to a network, Indigi doesn't categorize that as an engineering workstation. Generally, there's going to be industrial activities assigned with what these guys are doing. And going through the rest of my inventory, I can see, you know, things are running the way they should, but again, I just have these 2 suspicious pieces that I need to take a look at. So in order to to do the next step, what I usually would take us to is the the asset map that is going to give us a visual representation of what the industrial environment looks like. So each of these images has a lot of nodes on it, and each of these nodes indicates a piece of hardware in this environment. Some of them are PLCs, some of them are engineering workstations, cameras, SCADA servers, HMIs. If you're not familiar with HMIs, that's the human-to-machine interface. That would be like the panel or the LCD screen, things like that. They also get programming, and they are also usually a high-risk area of a lot of industrial environments. Reason being, some of them run old versions of Windows. They don't get patched. There is also a lot of interaction with them sometimes. There's a lot of people on them. So there's a few different things that you might want to focus on around your HMIs. So usually this particular network that I work with would look like this piece over here on the right, which is isolated. This is what I expect to see with my networks. I can see my engineering workstation here. He's talking to an HMI, and also the HMI and the engineering workstation talks to this particular PLC, etc. And I would expect to see in my environment 3 isolated air-gapped environments that are all doing their own industrial activities. So right away, there's my first network anomaly that I've identified, is that there's a connection between these 2 networks that I need to investigate. So let's just kind of zoom in here for a second and take a look at what kind of devices we see between these. First, I have a cooler here. This is a PLC, and I know that this cooler is worked on by Engineer 2. This is a Rockwell cooler. Engineer 2 is a Rockwell certified engineer. Engineer over here, Engineer 1, is my Siemens guy. And all the equipment that he works on is Siemens equipment. In fact, I don't even have the same software installed on these 2 workstations to both have them communicating with the same cooler. So now I've just identified another network type anomaly by using the visual representation of what a network should look like. And then I've got this piece. Here's my firewall. So I would expect to see my engineer talking out of the firewall because he needs internet access, and he would do things like search for code or work with vendors, etc. And that's going out of our external router. But what about this link right here? I find this to be suspicious as well. So why would my cooler, this is my Rockwell ControlLogix PLC that is controlling a piece of industrial equipment, and this has a communications channel with a firewall. So I do want to know more about that as well. So using the asset map, I am able to easily pick out several anomalies on the network standpoint, from a network standpoint. By the way, something else that we can do is we can click on these links to look at what types of traffic happen between these different devices. For example, between the firewall and the cooler, if I click on this, I want to see what these guys talked. And in this case, I have DHCP, which is when a new device comes on the network and you don't have a pre-configured address, it goes and gets the address from his gateway. So I shouldn't have that running in my industrial environment, and I also shouldn't have my cooler able to directly access the internet, getting IP from there. And so I definitely have some odd things to look at from a network configuration standpoint. It might also be that I have firewalls with misconfigured rules. That would also have additional lines coming out of here if maybe traffic is leaking into an environment that it shouldn't be. Here you can see linkages between these 2 environments in multiple different ways that shouldn't be there, including I've got a PLC with an HMI that is also being programmed by an engineer on this particular part of the plant. So if I want to continue our use case here, which is we have these unnamed, unmanaged machines on our network, we have anomalous inventory that we're trying to chase. So I'm going to focus on just these gentlemen and see what we got. So you can see we end up with two disconnected pieces of equipment here, networks. Here's unnamed 96, and here's the other guy, 51. Each of them had some communications with an industrial controller. So that is actually now getting a little scary. It's no longer that someone's on our network that we don't know about. Now it's become someone has communicated with an industrial controller that we don't know. And of course, the next obvious question is what did they do? And that's one of my favorite parts about our platform is that it's not just a single use type thing. It's more of an adjustable wrench that is part of a toolbox, and you're able to traverse multiple parts of the capability maturity model to answer lots of different questions, from the asset inventory to the anomaly detection stuff, as well as misconfigurations in the network, things that shouldn't be communicating with each other are really highlighted with this particular part of our product. So I'm going to now go from one level, which is I wanted to see who's communicating with what. Now I want to see what language are they talking. That's actually really important, because if this is DHCP, like what I just showed you, it's not as dangerous as something like an industrial communication. So I want to look at this communication, and first I can see this is Unity, and this one is Concept. Both of those are indeed industrial protocols used to affect the production of the PLC. It could be a variety of different actions taken inside of these protocols, and it could be reprogramming the device, it could be stopping it, starting it, or just doing a read from it. We don't really know yet. We haven't gotten to that level of detail, but you can see from the asset inventory I was at 30,000 foot view, and then we jumped into 10,000 feet view with the network asset map. By clicking on the different links here, we're getting down into the 1,000 foot view, and now we're going to get into, I would say, a 1 foot view by moving into the next part of the product. So we see now that these guys have had these communications. We know that they're scary. Now we need to know what they are. So I'm moving to now the activity trail, and this is something that is always on and always monitoring everything that it sees. And this is really important because, you know, like the adjustable wrench in your toolbox, the reason that we have an adjustable wrench is because it's too hard to say today what kind of nuts and bolts I'm going to be working with tomorrow. So I need a tool that is versatile and handles a variety of situations. And this is now where we have an audit trail of all of the activities that by itself may not have necessarily highlighted some of the risks and the use cases that we came across, but now it's becoming a very valuable tool in the forensic investigation about what these unnamed and unmanaged devices are doing on our network. So the first thing I want to know is, one of the use cases that we discussed was, do we have a malware attack going on? One of the first phases of a cyber attack and an early warning indicator is activities that look like they are doing reconnaissance operations on the network. So that would be reading things from devices, including code and firmware and the configuration of the hardware. And you can see in this environment, I have source and destination, timestamps, and records here clearly showing that I've got a lot of code uploads going on. But it doesn't look that scary. It's our engineer doing his job. And I'm scrolling through the records here, and I come down, and there's my first anomaly that I'm coming across. There's the unnamed guy doing stuff, unnamed 96 again. So there's a little bit of reconnaissance activity that happened from this guy. So we don't really 100% know what he's done yet in the other stuff, but we do know that he's at least read from our filtration system the code from that particular device. That could be indicative of a malware attack. So the next thing I want to do is look at this in reverse. Now I want to see, instead of reading stuff, I want to see if anyone has pushed, I did that backwards, sorry. I want to see if anybody has pushed any code from the device up or down. Let's take a look at both. And getting past all my engineering records, right away I can see that I've got non-engineers doing these types of industrial activities. They shouldn't be doing uploads and downloads of code on these devices. And as I'm looking at the unnamed machine that we're chasing here, I'm also starting to see indications of an HMI that is doing these types of operations as well. I should have HMIs. Remember, these are the panels. They're only usually configured to do a very strict set of operations. They only have dials and buttons and things that you could push that send commands to the PLC, but they're never used to rewrite the firmware or update the logic of the device itself. So first, let's just look at everything that unnamed machines have done. You can see that those two oddities that we highlighted earlier have actually done some industrial operations. And at the same time, I want to see if those HMIs have. So now my forensic investigation has kind of peeled off a little bit here from just those unnamed machines into there's a lot of suspicious activity here with multiple HMIs in the environment affecting multiple control systems. Again, these HMIs are never used to do things like download code to devices or change and modify the code that's inside in the running state of them. So this is also very suspicious activity that all of my HMIs are also doing these types of operations. And the activities that we would generally see in the activity console are important to audit all of the time, but we would also want to create security policies to highlight certain devices that have generated events that match a security policy. So in the case here, of which we had multiple use cases, multiple things going on, like a misconfigured network, firewall rules not working right, malware hitting HMIs, and unknown machines appearing on the network and doing industrial operations. You can see in this alert column, we would have had a long trail of alerts letting us know that this activity is taking place on our devices. And ultimately, what we're trying to do is protect the recipes and the code that lives on the different devices. So I also need to be able to jump in and take a look at the code that's inside of the PLC and understand what kinds of changes have happened. So for example, I'm looking at a Rockwell PLC here, and I've taken a snapshot of the memory, and it's come back to the Indige appliance for analysis. And Indige told me this tag called ARC for this webinar was deleted, and we added a new one for the output temperature. Also, inside of the ladder logic of the main program, we have a new tag for the ARC, as well as one for me that I deleted. So we need to be able to extend not just the asset inventory and anomaly detection from the hardware aspect, but we need to watch the network, and we need to watch the software that lives inside the PLCs. Without all of those components, you're really only getting a part of the picture, and you can only use this tool so far, or whatever tool you're going to use. You're only going to be able to go so far with it if you don't have the complete picture here. So, and I feel like that's what Indige is showing us, is from beginning to the end, from the hardware to the network to the software, what does everything look like? How did it get that way? And in the end, we're able to not just tell you were you breached, but also we're able to tell you, can you be breached? And if so, how would you be breached? And with that, I'm going to jump to our last slide here. And just in summary, as you can see, there's a lot of value in auditing all of the industrial activities in the OT environment. You don't know today what you're going to need tomorrow. Think about this like that adjustable wrench. Let's just record it all, and someday in the future, we will have a forensic investigation. Maybe it's malware, maybe it's someone that broke into the plant, or maybe it is somebody who accidentally loaded the wrong project onto the PLC. It could be any kind of a use case that we would want to refer back to an audit trail of everything that's happened and where it came from and what the impact of those actions were. Also, being able to look out for certain types of activities that indicate a breach or any kind of malware or bad activity, things like HMIs poking around, doing things that they shouldn't be. Understanding and being able to manage all of the assets in the environment are something that is critical to being able to do any kind of cybersecurity for an OT environment. And being aware of changes to that model are signs that something could be gone wrong. And I think that now I pass it back to Dana. I want to thank everyone for your time and taking a look at the product.
Okay, thank
Dana?
you, Chris, for a wonderful demo, very thorough and interesting. So I will stay with Chris's view. To summarize everything we've seen today, we've started with Sid's presentation. He talked about the current state of industrial cybersecurity. He then defined what industrial anomaly and breach detection is. So to remind you, breach detection, according to Sid and ARC, is looking for anomalous behavior within the endpoints devices. And we talked about agentless versus agent-based approaches. And then we talked about anomalous message detection, which is looking for anomalous messages being sent between the endpoint devices. And then we've differentiated between policy-based and behavior-based approaches. We finished with discussing the benefits of anomaly and breach detection. The security benefits include early detection of malware, system changes and malicious activities, improved incident management and forensic support. On the operational side, we talked about things like accurate asset inventories, early detection of problems, and operator errors. Then we moved to the Indegy part of the session, which discussed what Indegy offers. So the platform itself combines the two approaches that Sid mentioned before. So it's a combination of passive anomalous message detection, which is offered by CPI, control plane inspection, a network monitoring technology that focuses on identifying the types of communication between the devices within the ICS environment. And then the agentless breach detection approach, which is covered by ACV, which is Indegy's agentless controller validation, which detects breaches on the endpoint devices, being controllers in this case. And then, of course, we had the wonderful demo that Chris just finished with. So thank you both Sid and Chris for a wonderful presentation. Chris, do you want to switch slides to the last one? It's our thank you note. And as you can pass one more, but I will share with you our last poll question, which is asking, are you interested to see more? Please take your time to answer this question. While you answer this, here are a few questions that came up during the presentation. So the first one, I guess, is a question for me, and it's where's the skyline from? And honestly, I don't know. I hope you like it. We think it's pretty. The second question was, will the slide deck be made available? This session has been recorded, and we will make the recording available to anyone who registered for this webinar. You should get a follow-up email in the next few days that offers a link to view the recorded session, and of course you can contact us directly. Sorry. The next question is for Sid. Sid, the question is, within Sid's model of the state of industrial cybersecurity, are the program maturity owners changing at each increased maturity level, and who's responsible for the risk assessment at each maturity level?
In general, I would say, the bottom few levels, I think, are pretty much, a one-shot thing. Most companies, there's probably no one just at level 1 or just, but if they are, they're in transition to the first 3 levels. And those levels are more around putting in defensive type technologies, and really the way I'd characterize it is they're trying to reduce the likelihood of something getting in It's really kind of basic cybersecurity. And a lot of that could be managed by or implemented by people in the plant, the automation people. It could be done by IT. I think IT doesn't play much of a role in that as much as the plant people do. But as you go to the higher level ones, it shifts more and more towards the IT kind of groups being the ones who are controlling that type of technology and buying that kind of technology. And so it kind of shifts. I would say as you go up the scale, it shifts more and more towards towards IT, and mostly because of the expertise that's needed and what the interests are. I don't know if that answers the question, but hopefully I hit all the points? I hope I did.
Okay, thanks, Sid. The next question is to Chris. Chris, does Endigy have a way to detect whether a new 4-20MA sensor has been added to an industrial controller? If so, what would that look like? I'm not sure if you can answer that right now.
Yes. So yes, we would detect it if it was connected to the network. And there are a lot of different categories that we use to put different devices in. And we would first, as soon as it was connected, we would see it even if it didn't communicate. That's with our active component. And when it would be drawn on the network map, it would just look like an orphan and be sitting there. But you would still see it graphically and in the asset inventory. As soon as it started to talk to anything, then it would start to be drawn in the map and categorized and things like that. So yeah, we would see it, even if it's a device that someone invents today and puts it on the network, something we've never seen before, we would be able to determine whether it is and get it into the right category.
Fantastic. Next question is actually two questions. Ladies and gentlemen, please, one, would you please comment on layer 1 and 2 sensors and switches and other, not only on the controllers? And two, would you please comment on the time lag between intrusion and detection? Thanks.
Okay, I guess I would take those, or
yeah, I think so.
We split it.
Yeah,
okay.
I think they're pretty clear for you. The first one, though, I would make the point that you made just a moment ago about if you're actually doing breach detection, you'll see a lot of lower level things you may not find with just the anomaly detection. Anyhow, that would be my comment. But go ahead, Chris.
Yeah, so let me start with the second one, the timeline between the detection, or the breach and the detection. I think that there are a lot of times multiple places where you would detect a breach. It's more, a lot of times in retrospect, when you're doing the response and recovery operations and your investigation, you'll find that there are a lot of tools giving you a little bit of information. Sometimes it's the logbook at the front desk. It's a DHCP, like a record on the Active Directory side. It might be stuff on the industrial side. So piecing all that together is part of the putting the trail between the breach and the detection. And the earlier you can detect it, obviously, the better. Many times it is when the impacted device connects the first time to the network, could be the first sign of a breach if it's an unknown device, kind of like what I was highlighting. Sometimes something could infect the network and sit there for a while and wait, and then reach out after perhaps a month or two. And we've seen some nation-state tools that are able to operate very quietly. So it really depends on where you are in the entire life cycle of the breach, doing the detection, as well as the tool that is actually being used to infect the environment. I hope that answers the second one. Sorry, could you give me the first one again, Dana?
The first question was, would you please comment on layer 1 and 2 sensors and switches and others, not only the controllers? So I'm not sure if it's a discovery question, but we do discover these assets, right?
Yeah, so I think that usually I get that question in reference to the asset map and would it show all of the switches and things like that. So those lower layer devices don't usually participate in the IP network. They pass traffic. So we wouldn't really need, unless they're communicating directly with the industrial controllers, then we wouldn't have the need really to monitor those. For example, an unmanaged switch that's just passing traffic from one segment to another, Ultimately, we're worried about the end traffic that lands at the device, not necessarily the path that it took to get there, just that it did get there.
Okay.
But aren't they asking, can I ask a question? I don't want to interrupt on this, but I just want to clarify, because the way I interpreted that question was, and a lot of people ask me this question too, is everybody understands you can identify and see things that are on a network, on the upper level networks where you might be using, TCP type protocols and things. But it's a lot of people are concerned with the devices below that, maybe that are connected to a controller. That's why when I answered, I said I thought you would still detect that because you're looking at what is in the device, what is in the controller. And if you change the configuration, if you connect something, you should see that, I presume. So.
Yeah, I was speaking more in reference to the switching network, but you're absolutely right, Sid. When we're talking about the PLC, like, for example, a chassis with maybe a couple Ethernet cards in there and something down below that, or directly serial or direct connected I/O, etc. There's a whole lot of different second layer network stuff that could happen. Depending on how it's built out, most of the time we also can detect that equipment as well, because we have good understanding of. Yeah.
Sorry. I was just going to say that I think that first question too, with the 4 to 20 milliamp question, I think would fall into that category, but it depends on how it's connected, I guess.
Correct.
Okay, great. Since we're way over our time and people are starting to drop off, we do have some more questions, but we will take those offline. We appreciate everyone's time joining our presentation today. We hope you enjoyed the content and the demo. If you have any follow-up questions or want to schedule a demo, please let us know. You can contact us at info@indigy.com. You can also contact Sid at srsnitkin@arcweb.com. In any case, Indigy will be presenting at the ARC Forum, and in February. Until then, you're welcome to visit our website and follow us on LinkedIn and Twitter. Thank you again. We will share the link to the record presentation in the next few days. Have a wonderful day, everyone. This concludes our session today.
Bye-bye.